All right, good morning. Now, and just wait until most of you have come back. And today's lecture, we will mainly focus on the collision theory, and what's more is on the you try to take a look on the action of a catalyst on affecting the reaction rate. Okay, so last night we just stopped at here. Do you know where it is? And yeah, last night I have just uploaded it should be not uploaded the last night's video, as well as I have forwarded some YouTubes of other people who just try to get to know something more about the collision theory. Okay, so have you all read it? For those who understand what is that happening, could you please put a tick here? And for those who still don't know what's that, please put a cross. You understand? You understand what is that? You think that you really understand what is meant by collision theory? Collision theory. Collision theory. Odila, have you read that? Have you watched the video? Actually. So, Wenjing, have you? Not yet read, not yet watched any video? Have you watched it? Now, anyone who can tell me the main concept of collision theory? What is the main concept of collision theory? And to your understanding,劉文正, tell me your understanding about collision theory.
阿 Sir 聽唔聽到啊
？Collision theory, yes.
即係嗰啲 particles 佢哋 reaction 嗰時撞埋一齊，如果佢哋唔夠唔夠 kinetic energy 或者係佢哋唔係一個 buffer orientation 嘅話，就做唔到一個 effective collision 咯。即係要有兩個條件咯。
Yes, good. We have got two important points, right? You have just mentioned. Very good. So I would like to ask one more guys, right, to give you understanding about this. 雍正南 Are you here? 雍正南 Tell me your understanding about collision theory. Yeah. Try your best to tell me your understanding. Yes, we have got two important points. One is right orientation. The other one is enough energy. For the very good term, two key term, it is effective collision. Right, collision, we have got so many different types, but not all types of collision will lead to the coming of the reaction. We need to be very careful. So you to consider which type of collision of the particles will lead to a reaction. For those type of a reaction, we will call it as effective collision. Okay, so this is what we will call it as effective collision. So what are they? What are they? The best way to show it on the book, you may find it on page. Anyone who can tell me the page of the book. Where is it? We need to know the two, right? Collision theory. Yes, 45. You take a look on that. 45. Now this is the page. You just need to consider, and let me see if I have share this to you. They should be on. What are they? Yes, this way. Okay, you see that? Can you see that? So this is what we talk about it as collision theory. So you need to consider two things. One is whether or not they have got the right angle to collide. Okay, so you may see that right angle to collide. And second is on the enough energy. So what is mean by enough energy? Anyone who can have a elaboration? Because collision comes from the moving of particles, right? So what type of energy are we talking about? Yes, kinetic energy. Very good. Kinetic energy. 陳景希, you should be in biology class, isn't it? Right, this is Chem 1, and you should go to biology class, isn't it? So kinetic energy. So you are going to consider the kinetic energy which is able to, what is mean by the enough kinetic energy? What is mean by enough KE? What is mean by enough KE? Enough, right? A very subjective term. What does mean by enough? Wen Jiwei, can you tell? What does mean by enough? Move fast. Any reference point to tell it is fast enough or not fast enough? Any reference point? Yes, good term. If Ke of molecules at least greater than Ea, right? Ea. So what does mean by Ea? Ea, it is the activation energy. So what is that? What is that activation energy? Now, I would like to elaborate more on this. So activation energy, it refers to a chemical reaction like this from the reactant to product. So you know that we have got the delta H here, right? But it doesn't tell you the pathway. Okay, so for those blue line, it doesn't tell you a pathway. Indeed, that may be undergo the pathway like this. Okay, so undergo pathway like this, in which you need to supply certain energy to start the reaction, such that the reaction can proceed. I can give you one example like this. Okay, for example, hydrogen gas, oxygen gas to form water. So you know, this reaction, it is a very exothermic reaction, right? It's an exothermic reaction. It gives out heat. However, once I have got hydrogen gas and oxygen gas mixed together, the reaction will not go by its own. Okay, they will not go spontaneously. So what should we do? We need to have a spark, right? Now, for example, we have got hydrogen gas and oxygen gas. They will have no reaction. Instead, if I have got open the stopper and give a spark. I give a spark. So you know what's that, right? For example, electric spark. Inside that, what will happen? The hydrogen gas, oxygen gas will have got the fuel. We have got O2. We have got high temperature. So you know the phi triangle, right? So they would have a reaction. So the spark here refers to the energy, okay? Refers to the energy needed to overcome the energy barrier. So what is the energy barrier? The energy barrier here means, now in biology term, we call the energy barrier, right? So if you want to talk about the spark it is a type of energy. The energy it is higher than the energy barrier, while those particles, they will have enough energy and the reaction will go spontaneously like this. Do you understand? So because of this, it is energy profile, right? This energy profile, enthalpy level diagram, we have got one more. We have got a shape like this, right? So what is that? It is what we call that a type of energy profile, which tells you how the reaction they will proceed. So they will follow the orange curve to proceed, but not that the blue one and suddenly drop to the other blue one. Can you get a point? So we need to follow the steps of a hill, right? Go up and down. Well, if you want to consider how to overcome the hill, what you need to do, right? You need to consider to give it enough energy to overcome an energy barrier. Do you understand? So for writing down the energy for writing down the enthalpy level diagram, or it is just a start. We need to add some more based on this diagram. Do you understand? So what is that energy, activation energy, right? The minimum amount of energy, right, for the reaction to proceed or to start, okay? So this is what we understand about the collision theory. Understand? You get it, right? So remember that the energy profile doesn't tell you anything about the orientation. The energy profile doesn't tell you anything about orientation. So you need to consider the orientation as well. The orientation as well. That how there was the angle of hitting those particles, such that both factors they would match it and the reaction will proceed. Questions? Those who want to understand? Let me see. Do you understand a little bit? So you better refer to. We have got so many animations on the web, so such that you would know what is that, which is which. Okay, so and because of this, you are going to relate the case on the other factor or those four factors mentioned, which will affect the reaction rate. First of all, is about the increasing the concentration of the reactant. It will increase the rate of reaction. So in order to talk about this, you are going to consider the number of effective collision, but not the chance, right? Remember, it is just like the number of collision, which will lead to an increase in the number of effective collision per unit time, per unit volume, such that we will make the rate increase. Okay, this is what I would like to stop tell it in last night. And second is about the surface area of a solid, which tells you again the number of collision and hence the number of effective collision increase due to what? Due to surface area of contact between the particles. The colliding particles, they will have a more chance of hitting each other. So here comes the increase in collision. And because of the increase in collision, here comes the number of effective collision more. So, Lucy, you know the difference between collision and effective collision? Anyone who understand about these two terms? Collision and effective collision. Hi, Lucy, 李健朗 are you here? 陳俊喜 陳偉豪 tell me. Last night you just asked me question about this, right? Yes, collision and effective collision. What is the difference between the two?
Collision 係就咁兩粒 particle 撞埋一齊，就
Yes.
冇話有一個啱嘅角度或者個有冇足夠嘅 energetics 喺入邊嘅。但係 effective collision 咧就係有兩粒 particle 撞埋一齊之餘，佢哋係可以發生到一個反應，即係代表佢哋係有足夠嘅 Ke 去做呢個 activation 嘅，跟住仲有佢哋嘅角度都係啱嘅咯。
Okay. Yes, good. We have got going to consider the two aspects, right, to fulfill. First of all, the orientation should be correct, should be right. Second is about the energy. The Ke, the kinetic energy of a molecule, should be equal to or greater than the activation energy, such that we will say the collision effective. So collision, we have got so many, right? So we have got, because you may consider something like this, a number of collision is just a whole batch of a collision, right? But part of them, you just like call it as effective. Okay, so the particles, they will move it all the time, but not all particles. Once they hit together, the reaction will go. Only a small percentage. Only a small percentage of the heating, we will call that effective. Okay, can you get a point? So we are now going to, but if taking a look on these two cases, the pie chart here, right? The pie chart which tells you the effective collision, that one, the percentage of effective collision will not increase upon the increase in concentration or increase in surface area of solid. That pie chart is still that pie chart, okay, with that percentage amount that collision. But this time we just increase the number, okay? We just increase the number of effective collision, which means that the pie chart is becoming what? It is larger. Can you get my point? I want to make the pie chart larger, such that the collision will become more, right? The number of collision will be more, but still the pie chart with that percentage, same percentage, but we have got more effective collision. Can you get a point? Anyone who understand my saying, could you please put a thumbs up, let me know. I just want to make more collision such that they will have a more effective collision, but keeping the percentage the same. You understand? Great. So how about the surface area? The same. I would like to increase the pi, right? Such that we still another angle of the pi right on here to increase the number of effective collision. The percentage is still the same. You understand, right? But how can we increase the that slices, the angle of the slices? How? It is by what? Increase in temperature. Can you get my point? The temperature increase, that will lead to the increase in rate of reaction. So this saying, it is something like a pie chart. Pie chart on here with a small percentage on this, right? So if you increase the temperature, increase the number of collision per unit time, the more effective collision and rate will increase. But this time I increase the temperature, that will lead to an increase, general increase in particle Ke, and the fractions of molecules with Ke greater than Ea, so the change in effective collision increase and rate increase. So can you draw me another pie, right, to tell me the difference between these two? What is the difference upon the increase in temperature? What happened to the pi? Now the effective collision is originally like this. Same circle, same size as this circle. First of all, the size of the circle first. Bigger, same size, or smaller? the circle. What is meant by the size of circle? The size of circle means what? The larger the size of circle, which means what? Yes, more collision. So you draw the biggest circle first, okay? All of you draw a bigger circle first, like this. Bigger circle means what? Increase in the total number of collision, including those effective or ineffective. Okay, and second is about the pie. The slice of a pie is on that side, so can you change a little bit? The pie is on the green one, so what will happen? Yes, a bigger pie. Yes, a bigger pie, right? Can you see that? The percentage of effective collision will increase, and also together with the number of effective collision. Do you understand? Do you understand the two? Do you understand the two? Samson, do you understand what we are going to have? Good morning, it's now 9. Hi.
Good morning.
Hi. Tell me, do you understand what is that? I just draw the circle here. So do you understand what is that?
Effective collision.
Yeah. Can you elaborate more on that?
The colored part is the number of effective collision.
Uh-huh. And
The
then
colored part are ineffective collisions.
the number part, the shaded part, you mean the shaded part, it is the effective collision. So can you tell me the size, the difference in the size of circle and as well as the proportion?
A small fraction
Mm-hmm.
of the collisions are effective.
Yes. And then you just wake up, so you need some time for refreshing yourself.陳偉豪, try to tell him an understanding.
阿 Sir 可唔可以問多一次啊？
Try to show me your understanding about these two pie chart, right? Increase in temperature. How does the increase the temperature affect the rate of reaction in molecular viewpoint? With the help of the circle, yeah.
temperature increase 嗰陣，啲 molecule 可能會喐快咗啦，咁佢嘅 effective collision 就會多咗，咁所以嗰個 circle 隔離就會大咗啦，咁代表佢 effective collision 多咗，咁自然佢個 percentage of effective collision 都會多咗。
Mm-hmm. Now, you talk about the circle itself, right? The circle itself tells you the total number of collision. So including effective and ineffective, okay? So the one is failure, right? The one is in white, while the one that's shaded, it is effective. So why do I write down the bigger circle, first of all? The bigger circle refers to this saying. Now I would like to use 2 pen, right? The bigger circle it is on this, right? The temperature increase, number of collision per unit increase to increase the number of effective collision, you rate increase, which means this circle. Okay, I draw it in the bigger one. Okay, it will increase in the size of a circle like this, and because of that, you need this one to explain. Second, do you understand? Okay, second is on this. I would like to show you in this one. So the temperature increase, the Ke of molecule increase the fractions. The fraction of molecule with Ke greater than EA increase and increase the chance of effective collision. The chance fraction, which means what? Which means that pie chart, right? we've got a small slice and I would like to make a bigger size. The difference lies in the degree, right? For example, it is 10 degrees. Here comes 80, for example. Okay, you get my point. So if I make a larger percentage of this, which means the whole batch of the heating particles, we've got the more fractions, a higher fractions of molecules with Ke greater than EA, which means that the effective collision, the percentage means it is more or less refer to the degree right here will increase. Do you understand? You understand? For those who understand what I've just said, now could you please put a tick here? You still don't understand, please put a cross. Okay, most of you understand. 16, very good. 15, out of 20. So for the remaining 3 persons who just go away, where are you? Yu Zihou, where are you? Li Chut-jun. You just go out to the breakfast. How about Yu Yap-bum? Hi, 3 of you, you understand. Now here comes you understand. How about Yu Zihou Cyrus? So what does it mean by that? Right, so you know that percentage of those particles refer to the particles which are said to be qualified, right? In quotation, qualified to have a successful collision. Last night I just talked about something like a Christmas ball, right? In the case of a Christmas ball. You have so many cases of talking to girls, but but not every time you just talk to your girls and your girls will be your girlfriend. You know what? You can get what I mean, right? So the number of the talking of the girlfriends refers to the number of circle. Do you understand? If the circle is bigger, right, which means you just have more number of the chatting with the girls. But why would you say the bigger pie? The pie is more. The pie would have a more percentage. Right? It depends on you. It depends on you. If you are having enough energy, right? If you have enough level, will have a greater chance of having a, we call that effective. Do you understand? So how can we do? Is by increase in the Ke, kinetic energy of the particles. How? Increasing temperature. Do you still remember? Do you still remember analogy just last night? You understand, right? So how about these? Today, we talk about the catalyst. So the catalyst, for this part, it is different. Now, I would like to show you they are, that the presence of a catalyst will increase the rate of reaction. So remember, the catalyst here refers to the positive catalyst, right? The one which will make the reaction rate faster. For those catalysts which will slow down the reaction, even slow down the reaction, we call the catalyst and negative catalyst. So remember, you have got 2 types. Positive catalyst, reaction go faster. Yes, inhibitors in biology. Inhibitors, we call that in biology terms. So we would have that two scenario. We have got the 2 scenario of a decomposition of hydrogen peroxide. The one which place it on room temperature, normally oxygen will leave. Okay, oxygen will still form, but very, very slow. Very, very slow. But once I have added manganese 4 oxide, okay, it is a positive catalyst. It will make the decomposition faster. Okay, so this is the decomposition reaction. So the catalyst played a role in speeding up the reaction. So this is what we would like to talk about this. So what is the positive catalyst? The role of positive catalyst? Do they make the number of effective collision greater or smaller? No. Now it will increase the number of collision. They will not increase. Okay, they will not increase the number of collision, but they will not make the collision more energetic. But how can we make the pie chart bigger? Now, the pie chart is already here, right? A small pie chart here. We call it effective. So once I get the catalyst, so what will happen? The circle is still of this size, okay? Same size. But finally, here comes the greater percentage. So that is the role to play about the catalyst. Remember, the circle is not bigger. So which means that the number of the collision will not increase. Okay, and also the particles, the Ke of the particles is still the same. Okay, the kinetic energy of the particles still increase. Okay, the Ke is still the same. So how come we've got the bigger pie here? Why? Why? Now, so the positive catalyst, what is that? They will work by providing an alternative energy pathway of lower activation energy. So could you please put a star here and underline in the book as well? So this is the what we will say. How you understand about this pie here and also this sentence? I would like to show you the energy profile again. So what is the energy profile? Now the energy profile, they will show you something like this. So we have got the reactants to products. I try to treat it as a exothermic reaction, for example. The uncatalyzed pathway, we will have this. Okay, uncatalyzed pathway with this. How about the catalyzed pathway? The catalyzed pathway will be something like this. Okay, the catalyzed pathway. So what is that? So it seems like they would have a shortcut to make the reaction proceed faster. So when you compare the two activation energy, this one, the EA, will write in green one. When you compare it with the red one, it is different, right? It's different. So you may find this one, EA here. This time that is activation energy, EA here. When you compare to what? When you compare to the new activation energy, you may find that smaller. Okay, so do you know what is that? What is the meaning? What is the meaning about that? You still don't understand. Now, just like you go to walk from, for example, 慈雲山, right? 黃大仙, you go to 沙田, right? How? I ask you guys to walk. You can. So you have got so many ways to walk from 黃大仙 to 沙田, right? How? So you know that it is a lion rock, right? So you may first of all uncatalyzed pathway. Once you hear my term, somebody who just climb over the lion rock to go up to the peak of the hill, and then you go down. You go downhill and go to Sati. This is one way. Of course, somebody will have another way to go, right? There may be some shortcut. You need not climb over the highest point of the hill, such that you can go from 黃大仙 to Sati. Can you get my point? So the shortcut may be somewhere in which you will need less effort such that you can go. So this is what we call it as shortcuts. Do you understand? Shortcuts. So, or the positive catalyst, it seems like having a shortcut, right? You have an easier life. Okay, so that's why I will write it down in chemistry term. The catalyst provides an alternative reaction pathway of lower activation energy. And you may find it here, right? So I ask you guys to put a star here. So what is meant by alternative reaction pathway? It is a shortcut. Okay, do you understand? By doing so, I would like to lower the activation energy that will increase the fractions, the molecules with enough energy to react, which means that I make the standard lower, right? I make a standard lower, and for those particles, heating particles, or which are qualified to be effective collision, increase. Can you get my point? Can you get a point? So, which means that once you go to the, just like this one, the Christmas ball is still here, no difference, no difference. But I want to do something. I want to do something such that more people, what I mean is the percentage, the higher percentage of the heating particles, they are qualified to be effective collision. So I need to adjust. I need to adjust the minimum energy required for the reaction to proceed. Do you understand? For those who don't understand, could you please put a thumbs up here? Tell me now. Tell me now. You understand? Just, right, the best way to understand all those is by using analogy. You find the analogy useful? How about the other 10 people? Go away? Not understand? You understand? Good. You really understand now? So you would like to talk about that as a negative catalyst. How a negative catalyst? It's not shortcut. It will give you a more difficult pathway, right? So if you want to talk about negative catalyst here, negative catalyst, you go to a climb like this, right? Even more complicated, right? Using a negative catalyst. So because of this, you may make the reaction go more slowly because the activation energy here, it is much higher than the value between the normal uncatalyzed pathway. So what does it mean by that? I try to make the pie even smaller. I try to make the pie even smaller. So I increase the standards to a higher level, such that not all heating particles are said to be qualified to have an effective collision. Do you understand? Now, if you understand it, great. So here comes the examples. Some examples of catalysts in industry. So you need to memorize some of them. Do you know those chemical reactions? Do you know all those? Do you know what is that? So what are they in common? Can you see? Now, different catalysts, they are needed for their different reactions. So because the catalyst is actually to be specific, you need to change, right? You need to change different catalysts for each of the different chemical processes. But what are they in common about the catalyst? Can you see? What are they in common? The chemical, the nature. Yes, very good. Somebody who just write it down successfully. What is that? Yes, it is a transition metal. So all of you just write it down. Transition metals or the compounds or their compounds. So it means the iron, vanadium 5 oxide, platinum, rhodium, nickel. All those, they are just transition metals. So this is one thing I would like to draw attention. Second, how about the chemical process? What are they? They are quite useful, right? For example, if for Haber process, it is the chemical reaction involving nitrogen, hydrogen reacts together to form ammonia. Okay, so you know that ammonia, it is a good raw materials to make what? Anyone who can tell? Glass cleaner. But I would like to tell you, it will make you more consumption is on fertilizers. Do you know what's that? The one I sprinkle it into the soil, it will improve the agriculture rate of those crops. Second, it's about contact process. Contact process. The manufacture of sulfuric acid. You know what is that? Here comes this. The reaction they are now referring to is on this. And three, production of nitric acid. We would like to talk it as an osmotic process. We have got ammonia, oxygen, water to form nitric acid. Now, I would like you guys to search it by yourself. What is that? 4, turning oils into fats in the production of margarine. What does it mean by margarine? 植物牛油. So what is that? So you know that the 牛油, the term is very, very strange, right? But it is not a real butter, right? It's not so-called man-made. It's from vegetable oil. They turn from unsaturated fat, some unsaturated oil to saturated oil. If we increase the melting point of those oil, unsaturated oil, they will turn to saturated one. So it will increase the melting point of those and make that oil semi-solid. The semi-solid oil, it seems like butter, right? So you call it margarine. Yes, hydrogenation, very good. I need hydrogen and nickel, right? So you need some high temperature. So my the focusing point is on the operating condition, right? Usually for those in chemical industry, usually for those reaction, what should we do? Is to increase the temperature. Okay, is to increase the temperature. The acting of the catalyst, they will help make the operating conditions, what it means, the operating temperature lower. Okay, such that you can still get the proportion. Okay, the same proportion of the chemicals that you want. Do you understand? So the use of a catalyst, they will more or less save energy. Okay, but of course, the finding of the catalyst or the buying of the catalyst will add you the cost. It's up to you. Is from the economics viewpoint, you have going to calculate which one is more economical to you. Okay, which one can to give you more profit. So in the industry, normally we'll use catalyst because you need not make the operating temperature too high, and you can still get the same percentage of the product. Do you understand? Okay, so the operating temperature here can be lowered whenever I add catalyst, such that I can keep the same yield. Okay, do you understand? So this is what I would like to talk to you about the catalyst. So any questions? What's more about the catalyst? You may find that although they are solid. To mention this, although they are solid. So if you want to talk about the solid catalyst, normally speaking, they will use it as a finely divided powder, pellets, gauze, like this. Why is it like that? Because we will call that solid catalyst, we will say it as a surface catalyst. Surface catalyst, which means the reaction that will happen on the surface of catalyst. So of course, if you want to increase the reaction rate, you need to have a larger what? Surface area of contact. So under the term surface area. Okay, so increase the if you want to make the size of the surface catalyst smaller, which means the what? The surface area of contact between the catalyst and the reactants will increase, such that the reaction can go faster. Do you understand? For example, finely divided powder, right? The more surface area, smaller powder size. Okay, smaller particle size, they will have a small surface area. So will have surface area contact between catalyst and reactant increase, the rate will increase. Do you understand? Questions? So if all of you understand, or for those topic about enzyme, now it's something what you know it in biology, right? For those who don't know anything about biology, don't worry. So mark it enzyme in Chinese, boy. So what is that? It is what we call it as a biological catalyst. So catalyst, you know what's that? So the one I added, it will change the rate of reaction. Why is it biological? It's because of the nature of the enzyme. What makes the enzyme? It is made up of protein. Okay, it is a protein-based. It's a protein-based catalyst. So you may see one of the enzyme, the size of this, you may see very, very, very complicated. But what is that? The chain here in chemistry term, what is that? The whole thing is protein. In chemistry term, the chain, what is that? It is yes, it's a polymer. What is that? It is a polyamide inside. Okay, polyamide. A very long chain of this. And why would they will coil like this? And finally, here comes this shape. Do you know? I teach. It's time to talk about something about chemistry. Why is it coil like? First of all, why some part of it is coil like? You magnify it, you may see there is some interaction between the coil. What is that? Yes, because of this shape. What is that? Yes, hydrogen bond. So we have got hydrogen bond again. For those who still miss out those organic chemistry lesson, but you need to have a recap on this, right? So this one is a delta negative, high electronegative center here, and this one is negative hydrogen. So for polyamide, they will have this unit for a certain distance, okay? So they will coil like this, and in which the bonding in between, it is what? It is hydrogen bond. And because of this hydrogen bond, they would have a very special shape of this enzyme. The whole mold substances with the whole particle, they will have a very special shape. What we call it as a type of biological catalyst, enzyme. What's so special about this? So they would because of that, they will make the reaction very, very fast. Okay, per second, they will be able to catalyze the reactions in a speedy manner because of this catalyst. And for this enzyme, it's not just the human body, right? It's good for the human body, but also the scientists will make use of the enzyme and put it into industry or in daily life. How? For those laundry detergents, okay, some of them with those enzyme added, so which will help remove some biological stain, such like blood stain, food stain, sweat stain, for example. So the污跡啊. So you use those enzymes that will help remove the biological stain. Next time, while you go to the washing powder, yes, good, that's good. Once you go to the supermarket and try to see the laundry product, I must tell you there must be at least one product, okay, which will have the selling of this point, right? Something like enzyme. I added into it, and they will help remove those biological stains. 鬆肉粉. 鬆肉粉, it is just another thing, right? Yes, how would you soften the meat? They will break down some of the bond in the polypeptide, okay? It will make the mouthfeel of the meat, okay, softer. Okay, so the way to make it is by using some fruit juice. You may know it, some pineapple juice, okay, or apple juice, pear, papaya, etc. Right? So those fruit juice, once they would place it into the meat, right? I place it for half an hour, 1 hour, for example, the meat will be softened. Why? Because those enzymes can be found here. So what is that enzyme? In biology, we call it protease, a type of enzyme which will help break down the protein. So we call it protease. So in biology, we often play around those words. I try to make a splitting of the terms into two, and you may get, what is that? Okay, protein, ACE means a type of enzyme. So they will help break down protein. Very, very funny, but for those who biology, it's time to merge it with chemistry. For those who don't know anything about biology, don't worry. You have heard some of them, you learn some of that. Okay, so what is that? Why would you need to add enzyme to it? Yes, because you need not use high temperature, you need not use the high pressure to make the reaction go quickly. Right? If I can successfully find some enzyme, okay, it may help make the reaction condition less vigorous, less stringent. Okay, the experimental conditions will not be so harsh. Okay, and this is one of the aim of the chemists. They try to operate the oil industry in room temperature. So if I can successfully make an enzyme which can be operated in ambient conditions, which means room temperature, this is what they are now heading for. So what is the action of the enzyme? The action of enzyme is highly specific. right? When you compare with the surface catalyst in the previous page. For the surface catalyst, it is quite, an enzyme is different, right? For surface catalyst is quite general. I would like to show you, what is that? I would like to show you the surface catalyst action. So what is that? So once you talk about the surface catalyst, it is something like this. I would like to show you this page. Okay, so what is that? I cannot find the picture. What is that? Here. So the surface catalyst, just this one, just like this one. They provide a, can you see this one? So I cannot find it. It doesn't matter. I try to magnify this one. Can you see this? So what is mean by the solid catalyst is a type of surface catalyst which will help make a platform, okay, which will make a platform for the reaction to proceed. How? The platform that will help temporarily stick those particles here, right? Such that they will break the bond on the surface, they will form the bond on the catalytic surface before they leave, and then they leave. So this is what we call it as a type of surface catalyst. If you want to talk about this one, do you still remember what's that? A type of hydrogenation reaction. Can you see this? A hydrogenation reaction. So they would have, first of all, attach those hydrogen into it. So with what type of, that type of attachment, okay, what is that? We will call it as a adsorption. Have I told you what is that? Cupful. So which means a temporary binding. Temporary binding on the catalytic surface. And here comes the incoming of the ethylene, which is ethylene, C double bond, H, right, C2H4. And they will stick here, and you may find the breaking of the bond and the formation of bond that will facilitate, it seems the catalyst to facilitate the breaking of certain bond and forming of certain bond, such that the ethane molecules, not ethane, right? The saturated 2 carbon molecules can leave the surface. So the leaving of the surface, we call that as a desorption. Okay, desorption. D means without, okay? Do you understand? This is what we will call it as a type of a surface catalyst. How about enzyme? How about enzyme? Enzyme is just another case. If you want to talk about enzyme, now the enzyme, it would have a structure like this. Now, if you don't worry if you don't know anything about biology. So enzyme, that surface of this is very, very strange. Okay, what is that? Okay, it seems like a lock, key and lock model, right? It seems like a key, which means a type of a key. It is very, very special. So special that we will call that what? Specific. We will say the term stereospecific. Stereospecific, active site. This is what you know in biology term, right? Stereospecific in chemistry terms. Stereo means in 3D sense. Specific means they only allow certain shape of this. So what you will see is 2D, but actually is in 3D in shape. So we have got a substrate. Substrate, what is that? It's a type of reactant. If you don't know anything about substrate, don't worry. It's a type of reactant that will come to that surface. Well, when you compare with The normal catalyst is just a flat surface. Okay, this one is not just rough. That rough surface is specially designed such that certain type of reactant can only come here, but not all type. Okay, so we see that stereospecific. Can you get a point? And then they would have a temporary term. In chemistry, we call it intermediate. In biology, we call that enzyme substrate complex. And finally, the reaction then proceed here faster, such that, for example, is a type of breaking down process. Okay, that will facilitate the breaking down process. So what is that? The enzyme substrate complex you see it on the left hand side, it seems like the making again an alternative pathway having a lower activation energy. How? They will form this type of a complex and they will speed up the reaction. Do you understand? So that's why here you see the synergy between chemistry and biology. You feel happy? Do you feel happy about merging the two subjects now? Now, for those who did not study biology, a great chance for you to know something more. Do you feel happy about this? Yes or no? For those who feel okay for this chapter, right? He comes near the end, right? So for those who feel easy about this, could you please put a tick here? Put a tick if you know it, if you understand it. If you still don't understand, simply put across. You know it. Some of you know it. 李振傑, you just thumbs up. Where you 陳偉豪? You don't understand? 你同 understand? Yeah, good. 袁天佑, do you understand? 陳偉豪, where are you? Slept?
壞咗一嚿嘢，阿 Sir， 我剔唔到。
壞咗嚿嘢。So, shall we take a look on the conclusion about today's topic? So what is that? We just talk about mainly you talk about enzyme this time in this lesson. Enzyme, it is what? Right? It plays a role in provide an alternative pathway. Remember, this is a very important term. Provides an alternative pathway. Just like a shortcut, okay? So if you have got the positive catalyst, they will have a lower activation energy. So what is mean by that? I try to lower the standard, or somebody will try to put it like this way. I'll offer you a platform. I offer you a platform for the reaction to proceed. So that's why, what is mean by the positive catalyst? It is a type of a way, right? You know that. It is a Christmas ball, right? It is a place for you to meet the girls, to meet some other friends. Without Christmas ball, you know how serious it can be. 雷同. So it is a very, so you will much affect the batch of your schoolmates this year, because you guys cannot organize the Christmas ball successfully this year, right? So you know that it offers the platform for the reaction to proceed. So it is by increasing the chance of effective collision. Okay, such that they will increase what does it mean by increase the chance of effective collision? They increase the fractions of molecules with enough energy. What does it mean by enough energy? We have got the Ke, the own Ke of the particles. If the Ke is greater than or equal, at least equal to, or even greater than the activation energy, the reaction will go. Remember, one more point that you need to consider is what? You should know the orientation should be correct, such that you may know the reaction being a type of collision effective. You understand? And second, how about in the industrial catalysts that we have? Normally they are in what? Transition metals or the compound. Do you understand? And three, enzyme is just a protein-based catalyst. We call that a type of biological catalyst that may be found in the living things. So it's not just living things nowadays. In daily life, industrially, they try to extract them and put it into practice. Even outside the organism, they try to make that type of enzyme to improve the reaction rate. Okay, so here comes near the end of today's lecture. What do you feel? Tell me. While I'm not ask you guys to think to write down from 0 to 10, I would like to check the attendance finally. Who is absent? Tell me who. 蔡俊明、吳丁豪。Who? Who else? Could you please find your friend? If he's not here, let me know. 蔡俊明、吳丁豪。Who else? 20. Just irrespective of 陳景熙. And me, that should be 18. How about 5? 5 people absent. Who? 蔡俊明、吳丁豪。Who else? Tell me. Who? 袁天佑余日斌 are you here? 哦，趙家明。趙家明。Who? Who else? 徐家榮。4. 孔樂軒is in this class, right? So here comes the 4 absentees. 蔡俊明、吳丁豪、趙家明、徐家榮。Okay. So spend some time on reading the books again. Okay, and see you guys tonight. Okay, bye.